All right, today we're going to talk about angular velocity. What's angular velocity? Well, when something travels in a circle, how fast in the circle is it going? Okay? Now, would anything ever travel in a circle? You wouldn't get anywhere down the street if something didn't travel in a circle. Okay? Tires travel in a circle. Inside your engine. Oh, nice. Inside your engine constantly goes in a circle. What does RPM stand for? Revolutions per minute. Okay? This is a type of angular velocity. How fast something is traveling in a circle. Okay? So, when we talk about angular velocity in trig, we say that the angular velocity, which is W, equals the angle traveled divided by the time. The angle traveled divided by the time. So it's going to be in radians per some sort of time. Okay? So, let's say that you're running your engine and it's running at 4,000 RPM. Okay? What is the angular velocity that the engine part is traveling if it's going 4,000 RPM? Okay? Well, what we do is take the 4,000 revolutions, we'll just go rev, over minutes, 1 minute, and we'll change that into angular velocity. Okay? So, what did we say last time? How many radians are in a circle? 2 pi radians in a circle. How many revolutions is one time around the circle? How many revolutions is one time around the circle? 1. Okay? You go around the circle once, that's 1 revolution. So we know that there are 2 pi radians in 1 revolution. Well, revolutions cancel with revolutions, and we get that engine is traveling at 8,000 pi radians per minute. The distance that is going around is 800 pi radians per minute. Okay, that's the angular velocity. So we're going to deal with angular velocity today and just work with changing units. Okay, changing units. So let's say something was traveling at 36 revolutions per minute, and we want to know the number of radians per second of that. Okay, we want to change it from RPMs to radians per second. So we start out with 36 RPM, or revolutions per minute. And now we're going to change it to radians per minute. How do I change from revolutions to radians? Multiply by 2 pi radians every 1 revolution. And then, how do we change from minutes to seconds? There's 60 seconds in 1 minute. So minutes are in the denominator. So to cancel that, we need minutes in the numerator. So we need to multiply by 1 minute over 60 seconds. Okay? So you have to set up your your units and do unit conversion ratios. Okay? So it's 36 times 2 pi divided by 60. I know that 36 and 60 go into each other. Okay? I know that if we divide them by 6, this is 10 and this is 6, or 3 and 5. So we get 6 pi radians per every 5 seconds, or 6 pi over 5 radians per second. Okay, so 36 RPMs translate to 6 pi over 5 radians per second. Okay, now we come to the concept of linear velocity. Okay, linear velocity is straight line velocity. Linear velocity depends upon the radius of whatever's going around. Okay, so let's say a tire is traveling around at 20 revolutions per minute. Somebody's going really slow and they're going around. That tire is going around at 20 revolutions per minute. How far does it go down the road? Well, a big tire going 20 revolutions per minute will go a lot further than a little tiny tire going 20 revolutions per minute. So it all depends upon the radius. So if my radius of this tire is 10 inches, then we can tell how far it actually goes. Okay, so here we go. In 1 minute, how far will that go? Well, if we're going 20 revolutions per minute, we need to change it into radians per minute. Okay, so we multiply by 2 pi radians over 1 revolution. Okay, so the revolutions cancel, so I get radians per minute. Then I have to get inches involved. Well, I know my 1 radius of this wheel is 10 inches. Okay, so that's how radians cancels out, because they're involved in the radius. Radians, radius. So radian and a radius cancel when you put in the distance of, or the length of the radius. Okay, so now all of a sudden, I take 20 times 2, which is 40, times 10, which is 400. So I get 400 pi inches per minute. So it went 400 pi inches. Somebody calculadora, por favor. 400 times pi. I think that's 12.86 or 1286 in this case. Maybe it's 1236, 56, 1256. There's something like that. So in 1 minute, that tire will travel 1,256 inches. Okay? 1,256 inches. So that's the basics of what we're doing today. Now, let's say we have a table saw that its blade runs at 3,600 revolutions per minute. We want to know the linear velocity in miles per hour. Okay, so imagine you tip that table saw upside down and let the blade push it down the road. And if it's going 3,600 revolutions per minute, How fast would that table saw be going down the road? How many miles per hour would that be going if it had an 8-inch blade, 8-inch diameter? Okay. So, what do we start with, do you think? The 8 or the 3600? 3600. We start out with the 3600 revolutions per 1 minute. Now we have to get rid of revolutions and change it to, what if we change it to every single time? Radians, 2 pi radians in 1 revolution. We get rid of radians by putting down the radius. What's our radius? 4 inches in 1 radius, because if the diameter is 8, the radius is 4. Radians cancel. Now I want to get from inches to miles. Now I don't know what the conversion factor for inches to miles is, but I can go inches to feet. I know that in 1 foot there is 12 inches. Why did I put feet on the top and inches on the bottom? Because we need to cancel inches. So inches needs to be in the opposite place. How many feet are in a mile? Yep, and that's something everybody in here has to memorize. There are 5,280 feet in 1 mile. You all must memorize that. Poor Benedetta, she hasn't worked with feet and inches. She's just in the metric system where it's easy. You just move the decimal point, but not in America. There's nothing easy about us Americans. Yeah. So the feet cancel, and now we're in miles, but we're in miles per minute. I need to be in miles per hour. Hours goes on the bottom, so in 1 hour, I know there are 60 minutes. That's why minutes has to go on top. Minutes gets canceled with minutes. So somebody with a calculator, take 3,600 times 2 times pi times 4 times 60 divided by 12, hit equals. Divided by 5,280, hit equals. And what do we get? What do you get, Grant?
85.679.
So it's going approximately 86 miles per hour. That saw is moving right down that road. Okay? All right. Can you handle unit conversion ratios? Because that's basically what this section is about. Figuring out unit conversion ratios. We're going to spend today on it, and we're going to spend Monday doing a little bit more on this. And then Monday we'll also do some practice stuff for the quiz coming up next Wednesday. Yeah, or is it Tuesday? What? Mm-hmm. Okay. I don't know. This is a B day, so Tuesday you have class. Tuesday you have class, and Thursday we'll have a quiz. Wednesday is an assembly day. It's a weird day. No, that's on Wednesday. Tuesday we have an assembly, but Wednesday all day is like a weird day.